So in this video, we are going to model a rectangular simply supported beam, similar to the one we solved earlier using beams and line concept. So the first thing we're going to do here, we are going to start a static structural analysis system. We are using structure steel, so I do not need to revisit the engineering data because structure steel is my default material. I'm going to toggle back to project. Before I move forward, I want to make sure I have the right units. And today we are using SI units. So I'm going to go to units, and I want to be working in metric using kilograms, meters, and newtons. So here I have metric, or I can simply select SI, same thing, right? Next, I'm gonna start by creating my geometry. So I'm gonna right click on geometry and choose a new design modeler geometry to launch design modeler. I want my beam to have an axis along the x-axis. So I'm going to be creating my sketch in the YZ plane. So I can come here and select the YZ plane and choose to create a new sketch as a child of the YZ plane. I'm going to choose my view to be looking along the x-axis. And I'm going to toggle to sketching mode. And I want to create a sketch that simply has a rectangle, right? And then later on, we want to make sure we have edges on these faces where to apply the supports and apply the loads. So I am going to start by, and really there is more than one way of doing it. I can create these as like 4 solids. So I have these edges, or I can create one simple, and then I'm going to show you that I'm going to be adding or splitting the surfaces to create the edge where I can apply my supports and loads. Either way is going to be fine. So I'm going to go here and pick a rectangle. And intentionally, I'm going to show it off a bit. We are trying here, before I start actually drawing or sketching my rectangle, this is only 10 centimeters by 20 centimeters. So I want to make sure my scale is reasonable. So I'm going to come here, and this should be a reasonable scale. So in the scale here, we see so this is here is a 10 centimeters, and I'm going to sketch my rectangle, and I would like it to be centered about the x-axis. So here this is not restrained at all. In order to center it, I'm going to use symmetry constraints. So I'm going to go to constraints. I'm going to select symmetry. And this, I want it to be symmetric about the y-axis. So I'm going to start by selecting the line or axis of symmetry constraints. So I pick the y-axis. Then I'm going to pick the 2 vertical sides. So now it's symmetric about the y-axis. I'm going to right-click and say select a new symmetry axis. And now I'm going to pick the z-axis. Next, I'm going to select the top and the bottom edges. And now my rectangle is oriented properly on the YZ plane. Next, I'm going to put dimensions, and I want to have the horizontal or the base and the height. And the base here is V1, and I want this to be 0.1 meters, and my height, I want that to be 0.2 meters. So here is my rectangular section.
When you make your symmetry constraints, like, do you have to like generate it or something? Because I feel like it's not doing
No, the question here is about symmetry constraints. I simply went to constraints and I just picked symmetry and then made sure to select the axis of symmetry first, then the two sides. So now we are ready to extrude our rectangular section along the x-axis. So I'm going to select extrude, and this is going to create my part and my body. So I want to select the geometry. So for the geometry here, we are selecting sketch 1, apply. So here I have sketch 1 selected, and we're going in the normal direction, and the beam has a length of 10 meters. I'm going to generate, and here is my beam. So here I have the CAD 3D geometry, but I do not have the features I need for simulation, which I need to have it here. So the first thing that I'm going to start with is to create an edge where we're going to apply the load. And in order to do that, I want to show you here, if I come and select like the top face, I only have one continuous face. And I really want to have an edge or see an edge halfway through to allow me to apply the load.
How far did you extrude it for?
10 meters. The beam is 10 meters long. Right? So in order to split that face into two equal halves, I am going to start by creating a new plane from that face. So here I'm creating a plane from the face, and I have, it says here from face, and I need to select the base face. So I'm going to select here the top face. I'm going to say apply and generate. So now I have a new plane, plane 4, on that face, from that face. Okay.
Just to confirm the dimensions, so it's 2 meters by 1 meter.
No, the sketch is 10 centimeters by 20 centimeters. So it's 0.1 times 0.2 meters. You're welcome. All right. So now I have this plane 4. And on this plane, if I look at it, I want to split it halfway through, right? So all what I want to do is to come here and create the first step to do that. I'm going to create a new sketch, a child of plane 4. And on that sketch, I want to create or draw a line using sketching. I'm going to simply draw a line halfway that is constrained to the one edge. So I see the letter C, and I want to go to the other, and I want to see the letter V to indicate that it is perpendicular. So you see I'm seeing the letter C, and I'm not going to click until I see the letter V. So now I see C and V, I'm going to click, and here is a line. And it is light blue. It is not constrained yet. So the next step is I want to make sure to define the dimension. And the dimension is going to be from one edge to the other. So I want to come here and make sure we want to put a dimension. And the dimension is going to be between here. Oops, sorry. I'm going to put a dimension, and I want to pick the two. So this is one edge, and I'm using a horizontal dimension here, and I want to pick the other edge, and here is my dimension. And if I'm splitting this into two equal halves, this should be 5 meters. So I put here a dimension of 5 meters. So now my line is constrained. So I have a sketch. And next, I'm going to use a tool to split a face. So I'm going to say face split. And here I'm going to pick the target face, which is the top face. Let me go to 3D so you can see it here. So I'm going to pick my top face, and I'm going to say apply. And then the tool geometry, I'm going to pick the 2 points, the start and the end of my line. So here is my first point. Here's my second point. And this is the line that we're going to use to split the face. I'm going to say apply. Next, I'm going to click generate. And here now I have a face split. What did that do? If I come here and try to select a face, you can see I can select either the left face or the right face independently. So I was able to split my face. I'm going to repeat, if you missed anything, I'm going to repeat the same process to split the front and the back faces of the beam to allow us to create an edge representing the neutral surface where we can apply our supports. So I'm going to start here with the front face, and I want to create a new plane, and it is from a face, and I want to select the back face here. So I have a face selected, apply, generate, and here comes a new plane. It's called plane 5. I'm going to select plane 5, and under plane 5, I'm going to create a sketch. So sketch 3 is child of plane 5. I want to look on that plane. Fit. Okay, so here is my section. Here's my plane. And now I'm going to move to sketching. And again, I'm going to sketch a line. And I want to see the letter C almost halfway through. And I want to go to the other side and see the letter C. And I see also the constraint V. So that's a horizontal line. Click. And here is my line. Next, I'm going to put dimensions. And again, we can choose horizontal and put the dimension here. And if the height of the section was 20 centimeters, then half of it needs to be 10 centimeters. So I'm going to change this to exactly 0.1 meters. I'm going to go back to modeling, and I'm going to go to tools, face split, and I'm going to select the target face, apply, and the tool geometry. I'm going to select that, and I'm going to select the starting point of my edge. Okay, and my endpoint of the edge. All right, here you go. Apply. And when I generate, now I have a face split. Again, we can come here, and I'm able to select either the top or the bottom. I'm going to repeat the same process a third time for the front end. So here is now, this is the back end or point B. I'm going to repeat this process at the end of the beam, sorry, at the front of the beam. And of course here, if I turn on my planes, if I look at the XY plane, I already have a plane on the face that I need to split, right? So I do not really need to create a plane here, but I can create a sketch under the XY plane. So I'm just going to simply come here under XY and say a new sketch. I think I said that wrong. Not in the XY. We want that on the YZ plane. YZ plane. Sorry, that's the YZ plane. So I'm going to delete sketch 4 and go to the YZ plane. And I'm going to do a new sketch. And I'm going to go to sketching. Again, draw a line. I see the letter C. I want to make sure it's constrained to the right, to the edge, the vertical, right? And then I go to the other side. I see C and V. And here is my line. And it is already constrained because we had the axis. So go back to modeling. And I'm going to go to, again, tools, face split, select the face, apply. And for the geometry, I'm going to start here by selecting the points. See, I had my line. When I zoom in, I didn't have my sketch done correctly. So I'm going to go back to sketch 5, and we need to fix that. So I'm going to go to sketching. So let me delete this for a second. I'm going to come back to it. I'm going back to sketch 5, and I need to fix that. Sketching. Right. So I trimmed the extra part, and I need to come here and actually fix that as well. So I was misled by the constraints I was seeing because I was not zoomed in clearly. So now, oops. This is good. All right, so I think it may be. Okay, so I'm gonna extend that line here. Oops, no, that's not good. P, all right, that should be better. Okay, so here comes my line, and this is part of my sketch. Now this should be better. And now let's again go back and try to split the face. So I'm gonna go to a new face split tool, face split, and I'm gonna select my face. That's the face we want to split. Apply. Next, my tool geometry, I'm going to select the start point. And I want to make sure here when I select the point all the way to the end. Okay, say apply. Like that. Okay. We may have to create one line. Okay, so it doesn't like that my line is two pieces. I'm gonna go back to the sketch. So I'm gonna exit this, and I cannot leave it as work as progress. I'm gonna delete it. I'm gonna go back to my sketch, and I think I wanna just get rid of this and create a clean one. Are you sure you wanna delete sketch? Yes. I'm gonna create the sketch, redo it. So I have here, I'm gonna create a sketch that is simply gonna have a line to split the face. So that's sketch 6. I'm gonna go to sketching, and I'm gonna create a line, and I wanna make sure to zoom in here so we can see the edges. All right, so here is the C, and I'm gonna go all the way down. And I wanna see here that I wanna see the two constraints. I wanna see the letter V, and I wanna make sure that the C is to the pink edge that we're seeing here. Okay, so that should be good. Okay, this is not properly constrained, so I'm gonna put a dimension, and I'm gonna select horizontal dimension. I'm gonna pick one edge, pick the line, and put here my dimension, and this should be 0.1 or 10 centimeters. So that should do it. I'm gonna go back to modeling. I have sketch 6. I'm gonna go to tools, face split, and I'm gonna select my face. Let's go back to ISO so we can see what we're doing here. All right, so I have the face selected, apply, and next I'm gonna do the points to split, apply. All right, generate. And now I should be able to see each half separate, and we have an edge. We're happy with the geometry of the beam. We have everything we need. I want to make sure to save my project before I move any forward. So I'm going to save project. I'm going to call this 3D. Oops. Okay. So it became 3D. I'm going to leave it like that. And I'm going to double click model to launch ANSYS mechanical. So here comes my geometry, and always you should come and check that you have the proper material assignment. Okay. Next, I'm gonna go to my mesh, right? And if I check sizing, we have the default sizing of the mesh. If I pick sizing here, it says 0.49856, the default sizing of the mesh. So this is like 50 centimeters. This is not gonna give me a mesh I'm gonna like, but I really want a more uniform mesh, and I know the width of the beam is 10 centimeters. So before I even do anything, I'm going to go to the sizing, and I want to change the default element size to 0.1 meter. I'm going to next hit generate. Oh, sorry. I'm not done with sizing. I need to select a geometry. And please be careful. It is best to select the entire part. So I pick here, apply, and I picked one body. So I picked the entire body. And now I am ready to generate my mesh. And let's look at the mesh we got. We get here a quite uniform mesh that we like. You see, so basically it split the face into two halves, right? Next, I'm going to go to static structure. And now we are going to constrain the neutral surface, the edge of the neutral surface at point A and at point B. When we did that using line concepts and beams, we constrained a vertex. Okay. In real life, it's not going to be a vertex, it's not going to be an edge, but rather a face or a surface. So I'm going to apply a fixed support, and I want to make sure that I select the edge. So I'm going to come here and select an edge, and I want to select the edge that we created, apply. So here I have a fixed support. What is a fixed support doing? There are no rotational degrees of freedom. It is constraining the displacement in X, Y, and Z, which is what we expect or how we expect the beam to behave. The neutral surface is not going to elongate. Okay. On the other end, I'm going to apply another fixed support to the edge, apply, and here comes my second fixed support. Okay. Next, we're going to apply the 1000 Newton force on the edge at midspan. So I'm going to go to force, and I want to select my edge. Here and apply. I'm going to change the define by from vector to components like we did before. And I'm going to apply the force in the y direction downwards. So I have a minus 1000 newtons going downwards. Quick review. I have my two supports at A and B, and I have my load applied at C. We're ready to run the engine. So I'm going to click solve, and I want to get a green tick icon, meaning that I have a good solution. So I'm waiting here, and indeed we do have a solution. Do I need to do any fixed rotation to prevent this from spinning? We do not, because we're applying the constraints to edges, not to a point. So this is not going to spin about its x-axis, like when we modeled the beam using a line concept. Okay. Next, we want to explore the results. So I'm going to go to results, and I'm going to look at deformation, and I want to look at directional deformation. Yes, I want to check about the x-axis along the length of the beam, but I also want to look about deflection in the y direction. So let me show you an easy way to do it. I can right-click and say duplicate without results. So now I have a duplicate of the directional deformation, but I'm going to change the orientation from x-axis to y-axis. So this is really going to show me the deflection. And just to distinguish between the two, I can right click, and here is an easy way to rename it. I can pick rename based on definition. I am going to do the same with the x-axis directional deformation, rename based on definition. So now I have x-axis and y-axis. So before we do anything further, let me check these results. So I'm going to hit solve, and let's see what's happening here. If you look at the behavior of the beam, you can see that the beam is flexing in bending, and we're getting a deflection, and the front and end faces are able to rotate. So the rotation here, because I don't have a fixed support, you get this face to rotate. Hope you're all seeing that. Right. If you look at what's happening along the x-axis in terms of deformation, I get the same. Let me just stop this for a second. I get the maximum and minimum here, the blue and the red at the face. And remember, this is along the x-axis. Because the front face is going to get the most, because the middle one, the slope is going to be 0, right? But the front and the back face are going to get the maximum x displacement. And of course, it's very small, right? It's very small. If you look at the y-axis, though, this gives me the deflection. It is all negative. And where is the maximum? This dark blue. And by the way, if you come here and show, like, if I want to say, like, actually, it should be minimum, it is right at the center of the beam. This is where I'm getting my maximum deflection. If you recall the numbers, when we modeled this using lines, we were getting 1.5 millimeter. And indeed, we're getting the same result here using solid elements. Okay. The one thing that I can say when I fix the edges, this is as if I have two simple supports at the left and right end. If I really want to model a roller, the beam should be free to translate in the y direction. So if I want to model that as a roller, and let's see if it's going to affect the results at all. I'm going to come to this fixed support and suppress it. And instead of a fixed support, I'm going to put a displacement. And I want to apply that displacement to that edge. Apply. And I want this to be free in the x direction, but I'm going to fix it in the y and the z direction. And now with these changes, I'm going to have to rerun the solution. And let's look at the results. If I look at the y deformation, I'm still getting the 1.56. So really very small difference. You're going to see, even in the x direction, there is not much of a difference. There is going to be a very small difference in the results. But this is representing a simply supported beam with a pin support at the left end of the beam and a roller support at the right of the beam. Let's explore some more results. I can go to solution, and use probe to find the force reaction at the fixed supports. That would be the left side of the beam, and use another probe to find the force reaction at the displacement. I can use a probe to find the deformation at the center. So I'm going to pick my edge. Let's make sure I'm selecting the right one. No. No. Okay. Apply. And I want to look at the results in the y direction to look at the deflection, y-axis. Okay. So let's check these first. Solve. And we do check the force reaction here. I want you to see the arrow. So this is going upwards in the y direction, and it is 500 newtons. 500 newtons going upwards. If I check the other side, I have another 500 newtons. So the beam is in static equilibrium. The deflection at the center of the beam, again, is the 1.56 millimeters. Okay. What other results we can look at? Another interesting one would be, of course, the axial stress, the sigma x, which is equal to m over I times y. The bottom of the beam should be in tension and the top should be in compression. So if I come here and go to the solution, I go to results, go to stress, and I want to look at a normal stress, normal to the face, and which face? The x face. So I'm going to select normal and make sure that the x-axis is chosen. So you want to be careful with that. And if I hit solve, let's look at the results here. Normal stress. And look at this. Where the moment is maximum, we have the maximum and minimum stress, tension and compression. And they're both equal in magnitude. So I have a stress of 3.78 megapascal. And this is really a nice presentation about how this of the stress variation. You see the maximum moment is at the center. If I come to the edges, the moment is zero. And indeed, the stress is zero. If you go to the other side, the stress is also zero, right? At the center of the beam, the stress is always zero, the neutral axis. The stress is always zero, right? I can also check the shear stress. So I can come here and look at results and choose stress and choose the shear stress. And the shear acting on the beam is applied to the x face in the y direction. So I'm going to leave the xy component and let's solve. And if you look at the center, the shear is a zero. So you see the green. But the maximum shear is at the supports. So if you look here, I see a minus at the center. And remember, with the shear distribution, we have the parabolic distribution. The maximum shear is at the neutral axis. And we can see that here clearly. If I come to the other end, the main difference here that it is positive on one end and negative on the other end. So this is what a shear distribution looks like. You've always been drawing the parabola, but here's another way to look at the shear distribution in a rectangular section. We can also look at, go to results and look at the strain and choose the normal strain and choose the direction, the x-axis, right? So you remember the stress is related to the strain. So kind of you see the similar variation to the stress, but here I'm looking at strain values. So as you can see, we're able to see more with a 3D CAD model. We're looking at the stress distribution, strain distribution, not only the maximum combined stress or maximum direct stress, but we're really looking at the distribution of the stress and the strain with using the 3D CAD model.